All right, class, Algebra 2, we're going to be in lesson 15. We're going to be looking at a, um, a lesson that deals with elimination. And this is going to look like ordered pairs where we're going to end up with an x and a y, but this time we're not going to graph things, okay? So we don't have to worry about graphing these. We could, but elimination is more about an equation. So I'm going to start on page 80 and look at the equation x plus 2 equals 7. How would we find out what x is equal to? If I said x is equal to, well, I could think about it and say something plus 2 equals 7, and I could say, well, that's easy. 5 plus 2 equals 7. All right, but algebraically, how do we get x by itself? Well, we're going to subtract 2 from both sides, and if you notice, I am eliminating this 2, and the whole point of today is elimination. So what am I left with? Well, I'm left with 7 minus 2, which x equals 5. So if I substituted the 5 for x and said 5 plus 2 equals 7, I can see that my work is correct. Okay, so with that kind of idea, we're going to have two equations. All right, so if we have 2x plus y equals 11, and another equation of 3x minus 2y equals 6, how am I going to eliminate? Okay, well, I want to take a look at the x's and I want to take a look at the y's and decide which one can eliminate easier. Well, at first glance you might say, well, I can't really get rid of the x's and I can't really get rid of the y's because they're not the same. I would have to have a 2y because this is a negative 2y to eliminate. Well, how do I get that? Well, let's do this. Let's multiply the top equation by a positive 2 and multiply the bottom equation by a positive 1. And the reason is because I want to try to eliminate the y's so that I can solve for x. I can't solve for an equation that has two unknowns. I have to solve for one. So let's rewrite the equation. Okay, so this whole equation is now going to equal 4x plus 2y equals 22 because I'm applying this 2 to each term. Okay, multiplying it by each term. And if I'm multiplying the bottom by 1, I have the same thing. 3x minus 2y equals 6. Notice what I can now eliminate. Okay, I eliminated this portion because a 2y and a negative 2y totally eliminate out. Alright, so what's left? Well, if I add these together, now I'm going to have 7x equals 28. How do I get x by itself? Divide by 7, divide by 7. X is going to equal what? 7 divided into 28 is 4. Okay? So, if I now know what x is, I can go back to an original equation. We'll choose the first one, okay? If x is equal to 4, that means 2x plus y equals 11. I'm going to substitute the number 4 for x. So it's going to be 2 times 4 plus y equals 11, which means 8 plus y equals 11. So let's subtract 8, y equals 3. So x is equal to 4, y is equal to 3. And my answer is very much so that x equals 4, y equals 3. Okay? Elimination. All right. let's do elimination on question number, all right, we'll do 6. Okay, number 6 in your lesson, problem set 15. Here's the problem. 3x plus 4y equals 20. Negative 4x plus 3y equals 15. All right, notice on this one, the 3 and the 4 here and the 3 and the 4 here, it's pretty difficult because there's not an easy, we just multiply 1. We have to get a common denominator here. So either we're going to eliminate the x's or we're going to eliminate the y's. This time let's focus on the x's, okay? All right, so how can we make the x's equal each other? Well, if we make the x's equal each other, we could multiply the top by 4 and the bottom by 3. Excuse me, yeah, in order to get these to work. So 4 times 3 is 12x. 4 times 4 is 16y. 4 times 20 is 100. Let me eliminate that. 4 times 20 should be 80. Okay. And then the bottom, we have a negative 12x. 3 times 3 is 9y equals 45. Okay. Now we eliminated the x's because 12x and then negative 12x, they cross out. So what we're left with is adding these two equations up. So 16 plus 9, 25y equals 125. Divide by 25, divide by 25, y then equals 5, right? So let's take this number, so if y equals 5, that's half of it. We know what half is. We don't know what x is equal to. So let's take the original equation here, okay, right here, and we're going to, if we know what y is, we're going to put 5 in there. So it's going to be 3x equals 4 times 5, which is 20, equals 20. That's a 5. All right, so 3x equals 3x plus 20 equals 20. All right, so 3x, and we're going to subtract 20 from this side. I'm going to subtract 20 from this side. So 3x equals 0. We divide by 3, so x equals 0. Can that happen? Yeah, because watch, if we graphed that, x equaling 0 means that it's right there. Y equals 5, we'd go up 1, 2, 3, 4, 5. There would be our spot. X 0, y 5, or you would see it in an ordered pair like this. Okay, so this can be an actual answer, and for number 6, that's how you do it. All right, I'll let you do number 5 that way, and remember 7 and 8, they're substitution, so you have to show different work in order to get that. Okay, all right, that's your lesson today, lesson 15.